Thank you so much for joining us this afternoon. Amongst the 20-some thousand people here in many sessions, you could be anywhere. And I'm very grateful that you have joined us today. So with that, we'll kick things off. My name is Gracelyn Baskarin. I'm the director of the Critical Mineral Security Program at the Center for Strategic and International Studies in Washington, D.C. And before I jump into our panel of experts, I just want to, what are we discussing today? So I think there's a few things that are really fascinating than artificial intelligence and the nexus with critical minerals. When we looked at how much energy we would need going forward, and we thought about this a decade ago, a lot of people thought that our total energy demand would actually decline, stagnate or decline, owing to the fact that we were making big energy efficiency gains. But nobody really kind of saw what was coming for us in terms of the amount of power and the demand surge that we were going to have owing to artificial intelligence. Wells Fargo has estimated that we're going to have a 550% demand surge by 2026. And that's massive when you already consider that over 600 million people don't have any access to energy, particularly in emerging markets, adding to kind of the global energy shortage. And when you think that, I don't know how many of you use ChatGPT, I probably use it once a day minimum for something, whether it's drafting my email, but it needs about 10 times as much power as that Google query that we've been making for decades. So the fundamental landscape of what powers our modern economy is changing. And one of the big questions that I think our panel will touch on today is how is this actually shifting the demand for the minerals and the types of energy that we need? When we talk about net zero, we talk about phasing out our unclean energy and bringing in clean energy, but actually we need stable baseload power, and we're not just going into substitution where we're phasing out one and bringing another. We're going into additive power mode, which is again why you're seeing copper demand go through the roof. So I'm really excited today because we have just such a fantastic panel of experts here to unpack these, and I'm just here for the questions and to learn with you. So I want to start on my left. I've got Cyrus Hiramanak, who's the Senior Managing Director of M. Klein & Company and brings decades of experience globally working in emerging and advanced economies on this. I have Waleed Chetta, who's the president of Middle East and Africa at Schneider Electric. And again, just so much experience here. Fabio Fontana, who's the executive director of data centers at Autonomous. And then Majid Al-Omeid, who is the vice president of digital transformation at SNOT. So I am really excited. So I am going to start, Cyrus, with you. And I'm going to do one question straight across the board to get all of our takes on the same question. So my first question is this: in your opinion, given the experience you come from, how is the world actually going to meet the surge in power quickly? Because the AI economy is here whether we want it or not. In fact, it was here yesteryear. We're just catching up now. How are we going to meet that surge in demand?
Thank you so much. I think if we take a step back, and as you were talking about the surge in energy demand for AI, so today in 2024, the IEA estimates that about 1 to 2% of energy demand came from data centers. And over the next 2 years, that's going to double. So that's going to be 3 to 4%. If we look at the instances of compute that, queries or however you think about the world, between 2015 and 2020, there were about 500 million compute instances globally per annum. So it was pretty stable. And if you look at between 2020 and 2023, that 500 million compute instances have jumped to 1,250 million compute instances. So that's going to be, and that continues to grow as you have more LLM models, more AI, that AI get advanced. So that's going to bring a lot of energy demand. And if we think about it as how are we going to address this particular issue in the form of more gas-fired power plants? If you look at what in the US, the current administration and the new incoming administration is saying that for the base load power, for specifically data centers, they should put in more gas-fired power plant. There's going to be a more focus on renewables because renewables have to be part of that mix. And in addition, in the longer term, in the short term, you have your conventional energy, oil and gas, coal, but in the longer term, you'll have more of renewables, more of nuclear, and other energy sources like geothermal. And if you think about that energy infrastructure, then secondly, we have to improve the grid. In the US, the grid is old, it's not modern, so it's inefficient, so we have to make a more advanced grid. Like in Saudi Arabia, they invested and their grid is modern versus if you look at Europe and the United States, that grid infrastructure is very old, so you have to improve that. And lastly, and importantly, there has to be an energy efficiency gain from the compute unit. So if you think about 400 terawatts hours that were used for compute or data centers, about 50% of that energy is required for cooling. So to cool chips, that's not going into compute, that's to make sure that the chips cool down so that the computations can be run. So there is a lot of development of new technologies that are helping, like immersion cooling and two-phase immersion cooling, that will help reduce some of that energy workload.
I think you hit three great points: is building the generation, the transmission, and the innovation. I mean, I know in the US we're going through probably what's going to be our first transmission infrastructure upgrading in the better part of 50, 60 years, and we're not quite ready for it. So it's kind of upon us on a...
Yeah, just to add, if you just look at what is happening in California today, that infrastructure grid was put 100, 120 years, and doing that, ties back into the critical minerals, like copper is critical for data centers. It's expected that today that's about 80,000 tons of copper, and that's going to grow to about 160,000 tons. So, that interplay, we'll discuss further as we sort of move into some of the other questions.
I think it's a great foundation. Waleed, how are we going to meet this surge?
Yeah, so thank you for having me, and thank you for the comprehensive introduction where you mentioned, the 10 times more data and energy you need when you ChatGPT ask a question or compare that with Google. That, of course, generates a big demand in energy. We will multiply this consumption by 4 in the coming 3 years. And one very important point was said about the energy efficiency of all of that. So the answer of the question is, of course, more generation, but also more efficiency. And as you said very rightfully, a lot of it pertains to the cooling of the chips, not only to bring the power to the chip, but to bring also the cooling to the chip or the heat out of the chip to the chiller. And for that, there is a complete power chain of energy efficiency that can bring you more than 30% of less consumption or efficiency from what you generate. And that is not a small number, knowing that today AI-driven data centers only pertain for 1 to 2% of the overall electricity consumption worldwide. So when you multiply that by 4, you're talking about a scalability that cannot be afforded just by building new generation. Part of the answer is to microgrids, because you cannot transmit all of that, and you will come to that question about transmission and generation, but also a big part of it is pertaining to the cooling and efficiency. We are developing at Schneider Electric a cooling plate that will be studied with NVIDIA, by the way, and we are deploying that with the recent acquisition of a company called Motivair to do the R&D around that. Because, of course, when you are in an R&D environment, it's not at all as if you are in a development and production. A data center sometimes is very critical. It's just not only for looking for answers to common questions, it's sometimes used for very professional, profound questions to be asked or help in decision making. And in that regard, it's a critical power. When you speak critical power, you don't have right for downtime. Downtime, electricity with water is not the best thing to put together. So cooling through liquid is a big dilemma that we need to solve in the very short term. So power efficiency, cooling, and overall, of course, efficiency in generation. That would be the solution, in my point of view.
Absolutely, and those are very complementary approaches that are both equally necessary in terms of meeting that demand surge. And I think innovation is going to be a very strong theme that features here in terms of how we're going to do all of these things.
Of course.
Fabio, how are we going to meet the surge in demand?
Well, first of all, thanks for having me here. I work for NEOM, the project in the southwest part of Saudi Arabia, and our objective is to build data centers that are fully green by 2030. So first of all, just to complement what my colleague said very well about the consumption, there's been a big shift compared to 2 years ago. 2 years ago, we were talking about only hyperscaler. So we are talking about consumption in data center that range between 4 to 8 kilowatts per rack, which was not a lot. In the last 2 years, this is go up to about 120 kilowatts per rack. They're already designing rack up to half gigawatts. So as you see, it's a lot. But it's a lot not only for the change you can see from a Google search versus an AI search. Maybe, I don't know how many you know, just to put some number. When you do a Google search, your consumption is 80 minutes of a 60-watt bulb for a Google search. When you do a ChatGPT, it's a 9.5 more. It's about 9.5 bulb for 18 seconds. So you consume almost 10 times more. I'm very close to what my colleague said. Now, that means that if you look at the total gigawatts required worldwide, right now in 2024, we are talking about 81 gigawatts of power for data center. By 2030, they are predicting about 230 gigawatts. So it's a lot. That means that the carbon emission consumption, if we continue to use what we do right now for energy, we go from 200 tons to 600 tons or million by 2030. So what can we do different? From one side, definitely, we need to do an energy efficiency, as our colleague said. This is extremely important. Energy efficiency doesn't mean only on the way we build the chip, but also the way we use AI to balance the load of the server. So we do understand where we need the server. When you balance the load, you can balance the cooling you need. That's the first one, energy efficiency. It's also the cooling, as your colleague said. You do traditional air cooling, or you do immersion cooling, or you do water cooling. But this is not enough, because yeah, you can save energy, so you can decrease, but you still need a lot of energy. That is sometimes is almost 10% of what you need today. So the second thing is extremely important. We're doing NEO, how we can be green, looking combination of solar, wind, and hydrogen, plus backup battery. How we are going to do that? So we are building by 2030 10 gigawatts of solar panel. And in Saudi, we are blessed by the nature because we can have about 5 kilowatts per square meter of energy per day. That is much more than what you can get in any other country around the world. So that's the first advantage. Second, we have a lot of space to do that. Second, we are building 400 megawatts of wind farm because we have a lot of wind on the Gulf of Aqaba. That's the second thing. But still not enough because solar is only during the day. What do you do during the night with the data center? Yeah, you can use the wind, but the wind is not enough. Look at the difference. 10 gigawatts versus 400 megawatts. So what do you need more? You need, for example, hydrogen. Hydrogen, we build a big joint venture for hydrogen in NEOM that can help us to fulfill the need during the night. That's another important thing because there are applications that do not need consumption overnight. You take AI. As you may know, there are two types of AI, inference and training. Training doesn't need energy during the night because you can stop working. You can work only during the day. By inference, you need the energy 24/7. So that's where hydrogen step in. Hydrogen is very expensive. If you have close to your premises, you can have this one. So when you combine those three together, solar, wind, energy, that's the renewable, together with energy efficiency, and on top of that, as you discussed, the innovation you can apply even on the circular economy, then you can be fully green by 2030. That's where we are focusing over the next 10 years in NEO.
And I think Saudi, you know, we have so much to learn from it because there's a lot of greenfield project development happening, but also on the renewable energy front, having some of the cheapest wind and solar costs in the world, which gives it a significant advantage in terms of cost competitive
In
clean
space.
energy in the space.
Aerospace.
I mean, there's benefits to being in a desert. There's
absolutely.
challenges, but there's also many benefits when it comes to solar power.
Yeah.
Great. Majid, how are we going to meet this big demand surge we're kind of in the midst of?
I think we agree that, I'm not sure if we'll be able to answer this question after this great answers that came from my colleague, but it's clearly that the traditional way that's related to the gas, related to the renewable energies, identify specific minerals that would help in order to generate power similar to what you mentioned, that related to hydrogen and lithium, for example, for storage and sort of thing. And also there's an innovative, I would say, solutions that to reutilize those power to generate power by itself. And this would help also to reduce and identify another approach to generate this power through better optimization for the processes and maintain the energy in a better way. I can give an example. For example, 3% of the consumption in USA goes to the data centers. And we're expecting that by 2030, it will jump up to 11%. And this is, I would say, just a start, considering that with all those consumptions that used by ChatGPT, and I believe we did not start. And we should not ignore one more thing also. In NVIDIA, for example, they just announced that you can do AI in your house. You don't need a data center to do this, which means that there's another source of demand that will be created, similar to what we have in EV cars. So how we'll do it? We have to do all the options. We explore all the options. Good luck in you. But it is a serious issue that all the options that I believe that it's not enough to consider the demand that we will have in the next couple of years.
I want to pick up on your first point, because we are at Future Minerals Forum after all, so it does feel very appropriate to talk about the minerals that we should be targeting. Yes. We know that a lot of base metals prices this year had a really rough year. Copper went through the roof in 2024. Indeed. It hit an all-time high, indeed, owing a lot to that AI kind of demand. Yeah. Also, I don't know if you saw the Financial Times published an article the other day that uranium prices were being driven up, indeed, because of AI data centers, indeed, because again, you need the power from them. Indeed. What minerals should we be thinking about in this context as it relates to that AI demand surge?
I would say clearly that related to the power, lithium is the main, I would say, that mineral that's needed and required in order to maintain the power. Uranium, for example, it is a start. Copper, and I would say anything that would help us to create a power that it will need it. And for me, I believe that we need to explore all the options. Those are the three main minerals, but still, I believe that we will not achieve to support all the demand that we're having today, considering all the prediction that come in the future.
I think if I can add to that, that's on the power energy side. But if you look at the chip itself, so today the chip is silicon metal. And the silicon metal, as you increase the power density, that chip can't be stable with just silicon metal. So you need germanium and gallium. And those are two critical raw materials when 90% of the production or more comes from China. And so they are critical raw materials that are going to become increasingly important over the next few years as NVIDIA releases out the Blackwell and the other chips that are needed for that AI inference. So the energy density in the chip is increasing, and we need germanium and gallium.
And to that point, these are the commodities that have become the most weaponized when we look at restrictions globally, are really hitting at those semiconductor minerals, right?
Yes.
And so that's kind of a very interesting mineral space to come to. So one of the questions I want to start, so everybody, the rule now is everybody's got 90 seconds in the interest of time. How should we be thinking about cooling? What does it take? Cooling keeps coming up. We are obviously living in a climate era where cooling is important, it's difficult, it's getting warmer. When you're thinking about doing this at scale, we got to cool it. Oh, I'm going to open the floor quickly here. How should we be thinking about it? What does it take?
I think it has to start with innovation. You've got to get into, as you said, you're developing the cold plate for the next generation NVIDIA chips. But after that, you have to have a two-phase immersion cooling. And in two-phase immersion cooling, you don't need necessarily the water to cool it. It's another liquid that you can cool it, and you can actually put the compute, full compute into and immerse that into a liquid. And there's a company, it's a startup that's doing a lot of work that we've been working with, and they're working with NVIDIA like yourself, that over the next few years, and that would help improve the PUE, which is the power efficiency unit of the rack. Instead of being 1.4, it could be 1.08. So that could be a 30–40% energy efficiency that is currently being worked on. So as those gets released, you're going to see some benefit coming out of that.
I want to go, Fabio. We talked about this congruency between, our net zero ambitions, cleaner energy, emissions reductions, but needing to build a lot of energy baseload power really fast. Can we align kind of the clean energy transition with building enough energy at scale?
So we have a two-phase plan. The first one, because the energy demand is going very up on the data center, the current grid cannot cope because it's too much. So there are two phases we are doing. One is to greenify the existing grid, so to make it greener, but it doesn't happen overnight because the grid is going to serve not just the data center, just to serve the rest of the city. The second thing is to build facility close to the data center that it is not only renewable energy. So what we are thinking now is to look new technology. One is a small modular reactor. Those are first of all, they are safe. It's not like a nuclear plant. They are safe, they are small. But in a small container that is like this part, you can have up to 200, 300 megawatts. So it's a very new technology, but you need to go through all the process of approval and everything anytime you go in a new country, like Saudi. But that's something that can help to cope with the demand of energy in a very short time, a small nuclear reactor. The second thing is talking about what you say about cooling. So for sure, immersion cooling is a new thing we are looking, as you said, on the two-phase immersion cooling. We're also looking at water cooling, because the majority of the chipset, not only NVIDIA has 95% of the market share, but as you may know, there are new companies coming on the market, like Grok, like Cerebras, they are doing inference and training, and they are doing water cooling as well. So that means that even all the ecosystem need to adjust to the new way the cooling is going to be done, because it's not just a traditional cooling, you need to have liquid cooling as well. Last but not least, even in the cooling, like in energy, we are looking new technology, innovation like the small nuclear reactor. In the cooling, a new technology, we are start looking at that, even if it's not available before the next 5 years, is cryogen cooling, where you go down to 120 Kelvin. And that's what is being using today for the quantum computing. But again, the quantum computing is not ready before the next 5–10 years. But you need to start looking at that, because you need a different design. So to go back to your point, from one side, the grid you have right now is not enough, so you need to have alternative like small nuclear reactor. And the cooling, you need to be more creative of the way you cool. After the air, you do the immersion cooling, liquid cooling, and now cryogen in the future.
Thanks so much. So definitely cooling being a very key, and that nexus with innovation.
As you said, 50% is cooling.
Yeah. Walid, how do we improve efficiency? So efficiency is the other thing that continues to come up.
So what I liked about the comment of Fabio on the fact that you can use AI for improving the efficiency of AI-driven data centers. So the answer to the question is including AI. What we use is that we use softwares that run algorithms on the behavior of the data center. For buildings, for example, like the one we are in now, you can just use AI-driven softwares and reduce 30% of your bill of air conditioning, of lighting, etc., on the consumption of energy of a building. The data center is a building with a very heavy consumer that is the chip, but it's a building also. So when we speak efficiency, it's all about algorithms and digitization that will make the energy used, when it's needed, not when just to blow in some cold air into the data center or the water. I like very much the comment on the fact that when you are talking about training AI, you don't need the electricity in the night, so renewable energy and solar energy is very applicable. To manage that, you need advanced softwares that will use the experience of the previous days and years. which is typically what AI is doing, to implement during a given day, during a given week, the right structure of electricity that you will give to the installation that happens to be a data center. So for us, the efficiency, I would say 70% of it comes from software-driven solutions for the data center.
Very important, the software component. So one last question. Majid, I'm going to start with you, and we're going to come back around this way. What forms of power are you feeling most bullish about? Because when we think about the minerals for the kind of meeting the search, it depends on what kind of power. What is our baseload power? What is our energy mix? Are you feeling particularly bullish to nuclear solutions, gas, wind, solar?
I think that considering that the risk that we are having today, that the consumption is increased like crazy. We don't know exactly what will happen in next 3 years, assuming that, in 2022, we don't know what is ChatGPT. But today, it's a basic activity that can be utilized by any person, even my child. And due to that, I believe we need to have all the type of mix of powers. Gas, I think it will remain for the next at least 20 years, considering that still the other options is not mature yet, cannot provide enough energy, especially that Fabi just mentions, data centers. It's required electricity 24/7, which means that you cannot take a risk of having other options.
Fantastic. Fabio.
So it depends on where you live, where you are. So NEO, for example, we don't have natural gas. So for us, it's a solar today. But in the future, it's MRI, the small nuclear reactor. That's what can make the difference. What combined with wind, but the big part is solar for sure.
Yeah, I'm a desert. Benefits of a desert. Waleed.
Well, for Schneider Electric, we are not specialized in generation, but for us, what we do in our own operation is that we are targeting to be net zero by 2050, and we are well on track. And of course, the solar and the wind is a good mix, backed up with battery systems. But it's true that the base load, and you said it in the introduction, the base load is a topic when it comes to massive quantities. Then you will need the base load to be either nuclear or another decarbonized source of energy. At least this is our vision.
Fantastic. Cyrus.
I think we have to think about it in short term, medium term, long term. I think short term gas has to be the solution for base load. I think as we think about the medium to long term, I think renewables, nuclear and geothermal. So if you look at IEA is projecting that geothermal is going to be about 800 gigawatts by 2050. Nuclear is going to grow from about 100 to 300. So you have to really, because without that you can't have a clean energy transition and you can't have access to clean power. So I think all of the above have to be part of the mix if we are going to provide the world with reliable, low-cost energy, because that's the key piece.
I mean, I have a new sheriff in town, like you said, in a few days, and Trump is all about an all-of-the-above energy approach, and explicitly said AI, cheap energy for AI is really important. With that, thank you so much for joining us. Please join me in saying thank you to our wonderful panelists for bringing this fantastic expertise onto one stage. Thank you.
Are we good? Welcome to the next session. So please take your seats. We are now starting the next session, Voices from the Downstream. We will be talking about the importance of developing the processing-related part of the value chain and the downstream-related activities. If we look the development in this part of the value chain over the last years, some of the countries, for example China, has been taking lion's share of the processing capacity in the world. And it has become a major question that how do we have sufficient amount of processing capacity given the increased need of metals and some of the geopolitical considerations of this processing capacity, the location and where the metal gets consumed. This is an important topic because if we look the sustainability transition that is taking place, just the previous panel was talking about the increased energy consumption. For the electricity consumption alone, we estimate that 2050 it will be 2.5 times bigger the electricity consumption than today. Similarly, we will introduce in increasing volumes batteries, hydrogens, and so on. These are significantly more materials heavy ways of delivering the electricity and carrying the either electrons or molecules. For example, offshore wind takes more than 6 times more materials than the conventional gas or coal capacity to build. Similarly, EVs, roughly 20% more materials than the combustion engine is taking. So we will need significant volumes of metals for this sustainability transition. And as I already mentioned, there is an important geopolitical supply security considerations that are coming up increasingly now. It's not only about the origin of the molecules, but it's also where they are converted and beneficiated. So more supply in a sustainable way, cost efficiently, and in a supply secure way. That's the big theme of today's discussion. At the same time, the processing capacity has not increased like we would hope to see, and that's exactly the topic of today's panel. I'm extremely delighted to have 2 exciting panelists today with me here. Further from me is His Excellency, Dr. Abdullah A. Al-Ahmari. He is the Assistant Minister of Industry and Mineral Resources, Ministry for Planning and Development. And this is a position that covers a wide variety of critical areas, digital transformation, human resources development. There's a lot of data management, cybersecurity related topics, as well as planning and strategy. And he has vast experience from the last 30 years from the chemicals and then oil and gas industries from a wide variety of topics, and I'm sure that we will hear some of that wisdom today. Left from me is Mr. Faisal Sultan. He's the Vice President and Managing Director of Lucid Motors. And his role is to oversee the strategy for Middle East expansion and operations. And you have extensive experience from the automotive industry. I looked the number of automotive brands that you have worked on, and I think 4 of the car brands that I have used in my lifetime were on the list. So it's an impressive list and experience from. And you have seen the change in the industry, and we look forward hearing some of that experience. And before your current role, you looked after the industrial clusters development here in Kingdom of Saudi Arabia, and especially the automotive policy part of it. So Lucid Motors is also an inspiring company. Like we were discussing before the panel, it's a technology company that has decided to go also to the assembly part. So you produce EVs and also powertrains for EVs. We will now hear from both of the panelists opening remarks. They will talk a little bit about their point of view when it comes to the processing and downstream and some of these considerations that we just mentioned. And then after that, we have a couple of questions that we will be asking from the panelists. I would like His Excellency to start.
Thank you. Assalamu alaikum. Can you hear me? Okay, thank you so much for the introduction. I'm very happy to be part of this panel today to talk about very, very important subject. During the morning session with the ministers, we have heard a lot about the mining and the minerals in general. And I'm sure this session will focus more about green steel or green minerals in general. I know it's a very important subject, as you rightly stated. It's a very complicated and complex subject again. And I hope in this panel we will be discussing several areas, starting from the mining, to the production, to the supply chain, to the end user or consumer. We all know that steel is used everywhere, but the current production process, starting from mining all the way to the end user, is impacting our environment, and there is urgent need to switch to green processing, green steel, and green minerals. And again, I hope through the interaction of some of the questions, we will be addressing some of the challenges, some of the maybe technologies that we hope we will be implementing, and some of the incentives that we actually need in order to maximize the use and the production of green steel.
Thank you. Mr. Faisal Sultan.
Thank you so much, actually. It's a privilege to be here and be talking about this important subject. I think, look, you know, the way cars were manufactured, so when we talk about, let's say, minerals and metals, you know, the world really is beginning to now realize that the automotive and the transportation sector is going to play a major role when it comes to sustainability, making this world a better place. You know, electrification has to happen. And as we've all seen, electrification really was not taking off. You know, there was only one company that was trying to do it. And then now you see, you know, 300, 400 plus companies if you take all the Chinese counterparts that are in electrification. So I think electrification is the future. And when we talk about electrification, we must talk about the green metals, because electrification is going to have a large demand. We're talking about 20 folds of this rare metals and green metals and rare minerals consumption in the next 8 years only. And then beyond that, it's even hard to forecast what is going to happen. Where are these minerals going to come from? How are we going to make them cost effective? And basically the private-public partnership will have to play a major role, as we were discussing as we were walking here. If that doesn't happen, the consumer is going to suffer at the end of the day. So the whole point of doing all of this is to bring the policies, the incentives, the policies, the explorations, the innovations that really need to combine all of this and make a process out of it that results in a consumer getting a product that is better and it's readily available, the infrastructure for charging is available, and the metals are bringing the cost down of the vehicle at the end of the day. So I've actually seen it when I was working in the internal combustion engine side of things, you know, until 2017, 2018, you know, with Ford, with General Motors, with Fiat Chrysler, Stellantis, Magna, you know, all of the companies that I worked with, the supply chain was buying something completely different. You know, the core, you know, metals that were sought after has now completely changed. Now we talk about nickel, now we talk about cobalt, now we talk about magnesium, now we talk about lithium.
Yes.
Before it was, you know, cast iron and aluminum. They're still there. They haven't really gone anywhere. And the usage of them has also not gone down that much, unless you take the cast iron engine. But the car's body is still using the same metal. But it's the rare metals, the green metals. Where are we going to find them? You know, currently only 4 or 5 countries in the world if you can probably count them in your hand, have that capability. So with the Vision 2030, what I like is it's all about reading into the future and trying to bring that back and implementing it. And this is why you see such a great gathering here, because the country of Saudi Arabia, Kingdom of Saudi Arabia, is definitely investing in finding this, making it easier to explore and have it available for companies like Lucid who are localizing their manufacturing plants in the kingdom now.
Thank you. It seems like we agree with the importance of the topic and the need to take action. You were highlighting some of the collaboration models between the public sector and private companies. Your Excellency, from the experience that you have, what are the type of solutions, strategies, solutions that you believe are critical, centric in solving this question around expanding the processing and downstream capacity that will meet the needs of the more green metals, but also is cost efficient and supply secure?
Very good. Well, let's start with some facts. So again, the steel will be with us for life.
Yes.
The second thing, the burning platform is, every ton we produce today from steel, we produce 2 tons of CO2. So it's major contributor to the, the carbon emission. 8% of the total carbon emission comes from the factories of, steel. So these are the facts around the subject. Now, how to improve? We know a lot of efforts going everywhere to switch to green energy and green minerals. With that, there are some challenges, of course. First, the cost. If you ask today steel, plant to switch to produce green products, it's a lot of cost. So without incentives or some help from governments, for example, they cannot do it. It's very expensive process. The second thing is the supply chain itself. If you look at the supply from mining all the way to production to the end customer, it's very complicated. But unfortunately, there is a lack of transparency. You cannot track and trace exactly what you have in the supply chain. So you have to have some technologies. Just one example that comes to mind is the blockchain. If we implement blockchain that you can really track and trace all the movements, and you work with the manufacturer and suppliers to make sure that you have the right due diligence in order to make sure that they are producing green minerals or green steel, and then that will go through the process. So in order to expand, just to answer your question, there are few basic things that should be done first. Again, I think the price, the transparency or the technology, and some incentives that we have to provide to the manufacturing facilities in order to switch to green products.
Mr. Faisal Sultan, from private sector point of view and with your experience, what have been efficient strategies and solutions that you have seen in action?
When a transformation is happening at the beginning, as His Excellency was kind of saying, it is very expensive. And I think, typically incentives and policies really have to, it's a good balance that really works, is to have policies that are addressing some of those challenges, where it is the CapEx investment, the OpEx, from a training point of view, we talked about human resource development, all of that really needs to come together to make that expensive, become less expensive very fast. Yes. Because as we were discussing when we were walking here, if that doesn't happen, the technology becomes something that is not effective. And if that's the case, then the private sector loses interest and they take their money and they invest it somewhere else, right? So I think this needs to, it's a long-term process, but it needs to be shortened by innovation. So, there are a lot of technologies. I think one of the things that have not been done on the mining side, and I think, listening to His Excellency Khalid Al-Faleh when he was talking today, is one of the things that really haven't happened in the mining sector is the innovation. We're still doing things that like we were doing maybe 20, 30 years ago. And I think the new way of doing things will be to bring technology in, bring AI, bring blockchain, bring new methods like we were talking about. The seabed is full of minerals. It hasn't been touched. So yes, we dig these huge excavations and find mineral, but is there an untapped market that is just sitting around with some technology where it is more sustainable, more ESG governance, and then that can really bring the effectiveness so that the go-to-market is much faster. If that happens, I think we will all win, and I think that's really what is really needed, because the curve on the electric vehicles, if we're talking 2030 globally, 40 million electric vehicles are going to be in the market. 40 million electric vehicles are going to need 80 kilograms of this, and 8 kilograms of nickel, and 8 kilograms of cobalt, and 80 kilograms of copper. Where is this going to come from? Because if you compare it with the internal combustion engines, at least 1/4 less of these metal quantities were being utilized. So putting 40 million electric cars is like 160 to 200 million more ICE cars on the road when it comes to this metal usages.
Plus building the charging infrastructure.
Charging infrastructure is on top of that. So,
exactly.
So I think there's a big challenge in front of us. We need to find new ways to bring metals productions much faster, and I think the governments and the policymakers will really have to come together to find innovative ways that can bring that cost curve down.
Yeah. Coming from Finland, we have experienced the wind power boom, and today we are the lowest electricity cost country in Europe, and wind is the lowest cost way of producing electricity in Finland.
It's amazing.
It's amazing, and it has happened in less than 15 years. So 15 years ago, there was heavy governmental support, regulatory support that was basically enabling, and now it has gotten in 15 years to that cost-efficient way to produce. What, from your point of view, what regulatory changes should be considered and potentially developed in order to fast-track the development of processing capacity, green metals, locally produced? Maybe we start with His Excellency.
Yeah, sure. I think several, I can just mention a few of them, but let me start with something about, helping the plants or the production lines for more to be competitive. So there should be some help there. The second thing is just to enforce the use of recognized standards and certification system that's across, globe. Also, there should be something done for the procurement. So, in terms of putting green metals in public for public procurement from governments, and also some incentives for private sectors in terms of procurement to put priority for green metals. So that is still gray area that it's open actually today. You have the option, either you go this way or the other way. Also, the environmental impact, that should be emphasized also to make these requirements for mining and production and supply chain. Tax breaks and some incentives for either the supply chain companies or the production lines or the end user. And also, as you said before, the innovation should be enhanced and facilitated more in order to bring more ideas to bring, some products or some technologies that will help throughout this process.
Under your leadership, are you busy developing or planning in your ministry some of this kind of regulatory moves?
Correct. We have the digital transformation. We have also launched actually the innovation program within the ministry, and that will cover the whole process from idea to production. And we hope that we will be producing some of products or technologies that will support that direction.
We look forward hearing the outcomes on that one. Mr. Faisal.
So I'll just double down on what His Excellency mentioned. I think, look, the public-private partnership is, as I said, is going to be the key here. Technology is going to be number two. And when it comes to OEM, I think the demand is already there. We know that the electric vehicles, even though that the ramp up of electric vehicles that was forecasted 3 years ago has slowed down, but it's still a potential very, very large growth curve that is happening on electric vehicles and its infrastructure. So the demand is there. We definitely need to work. The OEMs also need to play their part. So what a company like Lucid Motors, our company, is doing is we're working with King Abdullah University of Science and Technology in what are the new ways to find this material, what are the material reserves available in the kingdom, around us, what can we do to tell them from a demand perspective, what is coming in our batteries in the future, what type of batteries are we going to use, so that they can concentrate on their research and development in the right areas, right? So that's a part that we really need to play. We're working with King Abdullah City of Science and Technology here in Riyadh to that aspect, also to bring in some more technology, digitalization, procurement skills, what is really needed to get this thing going in a much faster way to have these minerals available. And then we're working with our partners, like His Excellency, across all Ministry of Industry, Ministry of Investment, what are the key companies, the value chain, the supply chain that really need to exist in the kingdom to support us in the future. So the OEM has a very large, part to play here, and and then once all these blocks are available in front of us, we can all put the strategies together to come out with policies that will help, the consumer.
We have still time for brief closing question, and maybe this time we go with Mr. Faisal Sultan and then His Excellency. There's a lot happening in the world at the moment. We will next week, I think it's Monday, Donald Trump will be basically the president. There is increasing geopolitical tension, EVs, it appears like the EV cost point has really broken through, and in multiple countries, basically the EV adoption is clearly above the ICU adoption. For this audience, what would be your advice, what they should watch out in this space of processing and processing capacity downstream, if we look the year of 2025, be it globally or here in the Kingdom of Saudi Arabia, what's the advice, that watch out point?
Yeah, I think for the private sector, I would definitely say that there's a lot of opportunities. It really doesn't matter, which part of the government is going to come in or which political party is going to, the demand is the demand, right? Electrification is really happening. The sustainability focus is actually now coming back. So for a few years, it kind of went away. But now all of a sudden everyone is like, oh, Paris Accord, we got to do this. We're falling behind. Oh, there's these, floods. They're continuing to happen all over the world. All of these, the fires in Los Angeles. My daughter is affected. She had to run away from the university. So, these are real things that are happening to us human beings. And I think the sustainability is really going to drive, and therefore electrification is not going to go away. The efficiency has to be the focal point, whether it's mining, whether it's finding the minerals, whether it's producing an electric vehicle like Lucid Air that drives, the longest range. bringing the battery sizes down as we are trying to do and keep the range as we were talking. So everyone has to play a part to bring efficiency back into the equation. And with that, there's a lot of opportunities, a lot of opportunities for innovators to step up and find, what can they do to make this world a better place, but at the same time make some money.
Thank you.
Okay, well, I think the focus today is more on solar energy. While there are a lot of other, renewable sources, like the wind, like the geothermal and some others. I think we should be covering everything, because it's good to have, for example, from a production point of view, to have a hybrid, plant where you use the wind and solar and geothermal. So if you don't have sun, you can still run your plant. If you don't have, wind, still you can run your plant, and so on. So this is one aspect, is just to cover all, sources of renewable energy. Switching to, for example, hydrogen. Hydrogen is much better than other sources. But if you transport hydrogen from one area to another, it's risk and it's very costly, and it will reduce actually its efficiency.
Yeah.
So there are other things that can be used, like ammonia. I'm sure Faisal is aware of that. So for the audience, because we have mix from government, from private sector, from consumers, and so on, I think everyone should be working in his or her own area, but at the same time, we should be working as one team, and because the process is complex, as we stated in the beginning, and it needs to be addressed at all stages. Again, from mining all the way to production and end user or consumers.
Thank you. Thank you for the panelists for the interesting discussion, and thank you for the audience.
Thank you.
other one is off also? Ah, it's on? Hey, hey, hey.
بسم الله الرحمن الرحيم. Welcome to this landmark moment in Saudi Arabia mining and innovation journey. Today we proudly announce the launch of the Mining Innovation Studio, a public-private partnership aimed at solving the mining sector's biggest challenges through cutting-edge technology. Now, please Join me in welcoming the representatives of the founding partners for a group photo on the stage. His Excellency Khalid Al-Mdafir, Vice Minister for Mining Affairs, Ministry of Industry and Mineral Resources. His Excellency Dr. Munir, President of KAICC. Engineer Abdullah Shamrani, CEO of Saudi Geological Survey. Engineer Sulaiman Al-Mazrou, CEO of National Industrial Development and Logistics Program, NIDLB. VP Saud Al-Ataibi, Senior VP Saud Al-Ataibi, representative of Ma'aden. And lastly, Mr. David Belt, Executive Chairman, and Engineer Manif Al-Manif, KSA Managing Director, New Lab. We have with us also Engineer Ibrahim Al-Nasser, President and CEO of Saudi Mining Services Company, Asnad. Furthermore, we would like to welcome His Excellency Bandar Al-Khrayef, Minister of Industry and Mineral Resources, to join the group photo and celebrate this moment. Thank you and congratulations. Looking forward to the future of mining innovation. I would like now to introduce the announcement between the Saudi Geological Survey, Hawaii Tech Investment Company, and Xi'an Center of CGS. Welcome, Mr. Li Kang, VP Hawaii Tech Investment Saudi Arabia Company, and Dr. Yang, Director of Information Department, Xi'an Center of CGS. This announcement of the design and implementation of the data model and data management for the National Geological Database. Congratulations. Again, a huge congratulations for this key milestone. A big round of applause, please, to celebrate this milestone. Thank you for joining us. Now, welcome the Memorandum of Understanding between Aramco, Lithium Infinity, LITEC, Ma'aden, and King Abdulaziz City for Science and Technology. Join me in welcoming to the stage Mr. Nasser Naimi, Upstream President at Aramco, and Lee, founder of LITEC and Coast Professor. Saud Al-Ataibi, SVP at Ma'aden, and Sulaiman Al-Thnayan, VP of Government Affairs at King Abdulaziz City for Science and Technology. Allow me to welcome Dr. Saleh Al-Saleh from Aramco to join us on the stage. This memorandum of understanding to cooperate on lithium extraction from oil feed brines. Congratulations. هذه خلاص Now, if you allow us, I would like and I'm honored to give a moment for His Excellency Bandar Al-Khrayef to give a quick speech on these celebrations. Thank you, Your Excellency.
Wow, what a crowd, mashallah. I would like to start by saying this country is a country that actually turns dreams into reality. I was asking Suleiman just now, when did we visit New York? And he said at the beginning of 2023. We were inspired by how creating a space for innovation, for entrepreneurs, and for connecting private sector, companies with entrepreneurs, so much value can come out of it. And I said we should do something like this in Saudi. And now, today, we have it. So thank you, Suleiman. Thank you, Klaus, for So I'm very privileged as a minister. All I have to do is dream, and I have a team to make my dreams come true. Thanks to all of my team in the ministry, in NIDLib, in all of our ecosystem. What I would like to share also with you, especially here, with all the entrepreneurs, with all the creative ideas, what Saudi Arabia offers is actually very unique. Because each one of you, I can imagine, wants two things. You want money, of course, but also you want a place to test your technology, to test your idea. And this is the beauty about what we offer here in Saudi. You can find money everywhere, but it will be very hard to find a government that's willing to actually put its word, take the risk, help you connect with large companies like Aramco or Sabic or Ma'aden or other companies and test your technology, where you can actually get endorsement with real use cases. That by itself is very valuable, and this is what we are trying to do. So we will help you make your dreams come true, because this country is open for everyone. Dreamers, you are in the right place. Thank you for joining us. I wish you all the best. And please remember us when you succeed and you become a unicorn, because I heard there is a good list of candidates, almost 16 companies out of 1,000. So good luck, wish you all the best. Assalamu alaikum wa rahmatullahi wa barakatuh.
Thank you, Your Excellency, for these remarks. You just said, I have a team that can make our dreams come true. And I would like to say that we have a great leadership that can turn this vision into reality. Thank you so much for joining us. Your Excellencies and esteemed guests, see you tomorrow.
Do you want to say it? To close it off then?
Allow me, esteemed guests, we have a panel that will happen shortly. Please stay with us. Thank you so much.
Yes. Thank you, everyone. What an exciting time, exciting news. And what we'd like to do now is invite two esteemed guests to have a discussion on talent and technology. It's a great honor for me to welcome His Excellency Vice President Khalid Al-Muhtafai and Engineer Sulman Al-Mazroua. We are just getting mic'd up, and then we will have a conversation. It's a great honor for me to spend this time on the stage with these esteemed gentlemen. I have had opportunity to talk to them over the years and over the days. And what really inspires me is the sense of leadership and strength of that contribution. Wherever you'd like. Very good. Thank you so much for having me again. You had a busy day. Bob? Bob's not joining us. Yeah. Thank you. You comfortable? Thank you. So thank you very much for joining us. No doubt it's been a very busy and exciting time today and in the lead up to the Future Minerals Forum. Your Excellency, one of the questions that we've been contemplating is the talent gap in the minerals industry as one of the biggest challenges that we face. In your view, where are the challenges exactly, and how do we solve this challenge?
First, thank you very much, Jackie. You've been with us for in a different hats and since the first conference. And thank you very much for all of you for being here, and welcome to the Future Mineral Forum 2025. And the challenges that this industry faces, one of the most severe of is talent, as you said. The percentage of CEOs that had appointed talent as the highest risk, as one of the highest risk, is around 70% of the CEO survey. This is one because we had a stagnation of investment. There were no new generation coming in the industry, and the retirement of the expert skills that is going on. And on the other side, there is a drop-off or reduction in mining engineering and geology students. Or in Australia, where you come from, it's almost 40% since 2016. United States, it's almost 30% reduction in geology. Take this and compare it to the growth we're talking about in the mineral demand and how many mines and plants that we have to build to staff all these mines that will come with the demand we are forecasting. All these challenges are there. In Saudi Arabia, we have done our share. We have just opened a college or a section for mining engineering, thanks to the King Fahd University for Petroleum and Mineral Resources. There was no mining engineering there, even though there is a mining minerals are part of it, and also geology, rock geology. And we're working with the King Abdulaziz, which has one of the best school in earth sciences, the Earth Science College, to make it, to add to the quality that is there. But also there is a more requirement for training, development, and also utilization of technology. The new generation that we are having now are different from people like myself and Klaus, where we go in dusty places and look into books and papers and others. So technology is another opportunity that is coming up as we see today.
Thank you. And it's quite an interesting angle that you take there in terms of how technology and the pursuit of technology can really help solve this challenge. I'm interested in how you see that technology assisting that, closing the talent gap.
Well, there are many. Technology has the widespread from, is really the great opportunity that the mineral sector needs to unlock its growth and unlock its challenges. And from the way of learning, you can now do remote learning, but more important, we have seen a major mineral mining mines that are operated from inside the city. Remote mine operation is a reality. We have a team there in the technology zone where they are operating a mine that is 1,000 kilometers away. And also the exploration. There are more geophysics now, discoveries and satellite discoveries that are easier to do than our old day of prospecting and sampling. But also on the processing and exploring and artificial intelligence is given time. These jobs are better jobs for the new generation. They can be done out of the comfort of home, not even offices, and the cross-fertilization of maybe the geology and technology and mineral processing and selective optical capacity that to choose and be online is great. Quantum and artificial intelligence, these two can make the difference the future need.
So it's really fascinating that taking this challenge and turning it into an opportunity through technology and I suppose leading the way in terms of, again, Saudi leading the way in terms of how to attack a problem.
Yeah, we yesterday in the Ministerial Roundtable, we launched what we call the Super Region Center of Excellence, where we link research and developments and technology and innovation require network for use cases, require network of capacity. So we are linking all the best centers from Morocco, from South Africa, from Saudi Arabia to in one, and we established one called the Mineral Innovation Park in King Abdulaziz City for Science and Technology. And we have also launched today, you have seen it, and maybe Suleiman will talk more about it, the Innovation Lab with a new lab that will promote more innovation and more engagements. But also we are doing, as we explained, in the technology sphere that we're building with King Abdulaziz and King Fahad for petroleum, and King Abdulaziz University and the Saudi Geological Survey, a center for geological intelligence and big data analysis and online analysis to make more out of the data we have, but also to provide space for technologists to build, as we are looking for Saudi Arabia to be the capital of the mineral innovation.
Thank you so much. And if I may, Engineer Suleiman, your organization, NILDUP, technology is considered the foundation of the Saudi's vision. How do you explain how the innovation journey and how that initiative aligns with minerals industry needs?
Thank you, Jackie. I'm so honored to be with His Excellency, the same panel. Vision 2030 intends to transform the kingdom to an industrial powerhouse and a global logistic hub, and amplify the value of its natural resources. Technology is a cornerstone of how to leapfrog to achieve that. We are not China or India when it's come to manpower, but we have a secret weapon. Our brain power. We have tech-savvy engineers that, with technology, the factory that's run by thousands can be run by hundreds using automation, IoTs, and technology. And with technology, we can achieve productivity with competition and competitiveness. We can achieve sustainability with efficiency. We can achieve scalability with safety. So it's the right tool to use to leapfrog to achieve what we intended to achieve, to be an industrial powerhouse and a global logistic hub. And with NIDLIB initiatives that executed by a great agent on different government entities, is actually having the right infrastructure, the digital infrastructure of 5Gs, to make sure that companies, they have the ability to reach the internet and their back-end systems. We have the solutions in the capability centers and encourage them to use the best to be competitive on the global markets. And add to that the amount of innovation that we are trying to encourage for them to achieve their potential market seek and potential technology advantage that they need to. So this is what we are trying to do in NIDLIB to make sure we achieve the targets that we have.
So really enabling the vision as the backbone. Are there any pilot projects that have been spearheaded by NIDLIB that demonstrate the innovation in enhancing mineral operations?
So innovation, Saudi Arabia is the perfect place for innovation. And His Excellency, Mr. Bandar, mentioned how unique Saudi is. But if you think of Saudi, that a country with a lot of desert and have the biggest initiative of a green Saudi, or a country that have this amount of massive reserve that have never been explored, and now not only exploring, but exploring and processing on the same time. A country that have not known for a lot of know-how, but yet building the most innovative city in the world called NEOM. It may sound counterintuitive to anyone, but to innovative people and innovators, they will see this the best use cases place in the world. Add to that the amount of leadership, the power of leadership, of commitment to make sure that the enablers and incentives required to achieve your dream is there. Add to that the purpose. Vision 2030 has the right purpose. It's working for Saudis, but also for the international community too. Whether it's saving the planet with clean energy, whether it's contributing to the global resilience of supply chain with the medicine, food security, all that embed on the purpose of Vision 2030. So whoever is working with Saudi companies or Vision 2030, he contribute already to the international community and the global initiative too. So these three aspects, the condition that we have where we are for example, the largest oil and gas producer, and we're still looking for the 50% mix of renewables. These conditions be the perfect fit for any inventors who would like to use these use cases and come up with the invention they need. And with the commitment we have from our leadership to help these inventors, we have, today is a great example. We are partnering with a new lab. I see David is standing there. We are partnering with a new lab to bring the best founders around the world to share with us the challenges. They are not, and we announced it today with the President of His Excellency, we are not solving only challenges that we have in Saudi only, no. We solve challenges that we solve for Saudis and for the international community. And everyone is so excited to pilot in Saudi, then take their solution to the world. So for the inventors available with us today, this is the perfect place for you. Please apply to the challenges that we announced today with a new lab. There is a place for you. And for the investors, this is the best time to invest in these companies before the pilot happen and their evaluation goes skyrockets. As you mentioned by His Excellency, most of them will be unicorn very soon. So I think we should be taking advantage of this platform. Thank you, Your Excellency. FMF is a great platform for everyone, whether it's an investor, inventors, founders, seeking knowledge. So thank you for having this great place.
Thank you. And I could extend that thanks.
Thank you. Thank you. Anas, I think what Suleiman has been saying is the right thing. And before, His Royal Highness Prince Mohammed, when he launched the Vision 2030, said this is the land of dreamers. We want dreamers, only dreamers of the world, to work with us. And there is no better field than minerals for innovation, because it has maybe 100 years of lacking behind other fields. So now, and this time is the age of mineral. So the age of the Saudi Arabia, it's a place for dreamers to make to turn their ambition into action and their vision into impact. And the minerals is where the potential is, because the requirements for innovation in this sector is equal only or compared only to the health sector, which is way advanced than the mineral sector. So a great combination for the innovation hub to be in Saudi Arabia and in the mineral sector. Thank you very much, Jackie.
Thank you very much. Please join me in thanking our esteemed guests for their valuable contribution to our community. Thank you.
Okay. Well, good afternoon, everyone. We're just sure that we are here. Well, my name is Dennis Gibson. I'm the chairman of the Critical Minerals Association USA. And I've actually had the privilege of working in the mining industry for many years, 20 of which was with Rio Tinto, one of the world's largest mining companies. And I have had spent many hours traveling to various operations around the world, looking at the importance of water and energy and so forth, And that was way back in the early 2000s. And a lot has happened since then in terms of moving towards scope 1, 2, and 3 emissions. I know scope 1, 2, and 3, everybody here knows all about that, but I'm actually going to just have a look at why the mining industry is actually focusing in on scope 3 emissions. And that really reflects the shift in environmental responsibility and sustainability practices within the sector. Scope 3 emissions are the emissions that actually occur from the company's value chain, including the upstream and downstream. I'm not going to go into too much detail because I've got some experts on the panel who will actually talk about the specifics of scope 1, 2, and 3 emissions. The shift has been driven primarily due to regulatory pressure and compliance, investor demand, market competitiveness, supply chain transparency, and sustainability goals. Why is the mining industry now looking at scope 3 emissions? And I'll add in, and should they? Is not part of the question, but it's something that we will be covering. Our panelists, I have Bhagyesh Dash, who is the Senior Commercial Director for the MENA region and Director of Climate Change, or Climate Project Structuring at South Pole, and he is based in Singapore. Emily Olsen, on the other side of the stage, is Chief Sustainability and Corporate Affairs Officer at Vale Base Metals. Emily is responsible for driving global strategic initiatives at VBM, and that's inclusive of government and strategic partners and various external organizations. And she oversees the company's ESG program, including the strategy, community engagement, environmental stewardship, low carbon projects, and sustainability reporting. Jay Hambro, next to her, is the Chief Executive Officer at Vidagris Strategic, and Jay is based in London. And they focus on strategic consultancy for mining and metals downstream, plus the downstream and industrial sectors, and really specialize on integrating circularity and vertical integration into business and investment strategies, particularly for companies looking towards the energy, towards transition to balance sustainable practices with long-term profitability. Kay Wang is next to Jay, and she's the global lead for energy minerals, and circularity at the World Resources Institute, based in the Netherlands. WRI is an environmental think tank that goes beyond research to promote practical solutions to the world's most urgent and challenging environmental problems. I'm going to kick straight off and look towards them to answering a number of really key questions. First off, Emily. I'm going to start with Emily in terms of looking at the importance and the background towards what we mean by scope 1, 2, and 3 emissions, and where can you as Vale have the greatest impact?
No, can you guys hear me? Oh, there we go. All right. So Dennis, you covered very nicely what scope 1, 2, and 3. I think this has become a common vernacular for most businesses over the last decade, right? We all are clear on targets and the role we play in reducing emissions globally, and particularly the mining sector. Though we are not, we do our part in those emissions, but really how we start to look at a decarbonized mine. We're talking about scope 3. I think for mining coming into this journey, right, Vale has its own targets of 33% reduction of scope 1 and 2. We have a 15% target for our scope 3. And I would say scope 3 is still a bit nascent. It's one of the trickier elements of abatement and how we tackle it. And so when you look at capital allocation in a mining company, really looking at the value added investments, particularly in decarbonization. So when we look at our own portfolio, you're really tackling our scope 1 and scope 2 well. Vale is blessed with a very renewable energy portfolio. So our scope 2, are something very easily managed by us, but scope 1 being hard to abate. That's diesel in our haul trucks. It's all the things that we control. That's harder to do in remote mine areas. So for a mining company like Vale, you're really focusing on what we can do and can deliver. And then looking at scope 3, like I said, I still think this is a fairly nascent conversation in the climate debate. And you pose, do we need to? I think really mapping your suppliers and understanding where those emissions sit in the downstream is really important. Being clear on what you're trying to solve. What are the targets? What are the standards we're looking to achieve, right? I think a lot of work needs to still be done on that scope 3 to make it as robust as companies can on scope 1 and 2. So, I think this is the start of that scope 3 journey.
Exactly, and thanks for sharing that. And I'm going to actually ask Bhagyesh the same question. Particularly, how can we have most impact? So really, scope 1, 2, and 3, for a lot of folk in the room, may be familiar, but for those who aren't familiar, it actually just helps to reinforce.
Sure. So, hello. Yeah. So what we have is, I think Emily's provided a brief description of the various scopes. It's a way of describing the 3 types of emissions any company or organization emits in the form of carbon dioxide and greenhouse gases. Scope 1 is basically emissions directly related to a company's operations, something that is connected to activities that it owns and operates. So we are talking about, if, for example, a company owns a building, has a boiler, and that has emissions, that's related that's a scope 1 emission. A fleet of cars, in the case of a mining company, if it owns a fleet of vehicles and equipment, emissions associated with that are categorized as scope 1. Scope 2 is essentially electricity consumption. So, every business consumes electricity, which is supplied by a power distributor, which is connected to fossil fuels. That's your scope 2 emissions. So you have influence over it, but you're not the owner and operator. And scope 3 is connected to activities that you don't own and operate, but they have a connection to your activities. So in the case of a company, it would be travel by employees, waste management. In the case of mining companies, it would be the use of sold products or the processing of sold products, waste management, and that's your scope 3 emissions.
And what's interesting is when I was traveling around doing the target setting back in 2004 or so with Rio, we were traveling around the world, and the one thing that we never thought about when we were looking at water and power, energy type of targets was travel. The aspect of travel, because I don't think anybody even thought about what is scope 3 back then. So that's quite interesting. Jay, during our dinner conversation last night, I picked up that you're particularly passionate about circularity. What role can circular strategies play in decarbonizing scope 3 emissions?
That's an interesting one. Oh, hello, can you hear me? Yeah. That's an interesting one, Dennis. Thank you. So I did a presentation here yesterday on circularity and explained how I'm very passionate about it, but for those of you who weren't here, I focused a lot on recycling, but it's also on how industry is looking for making equipment last longer, and that's through a redesign process. It's making sure that we are reusing equipment where we can, and I think that fits a lot with scope 3. The scope 3 process it has a flaw because you are dependent on a third party. And it also makes it somewhat discriminatory because that third party has got to be up to your standards. So not all third parties can comply. If you have a fully circular solution, like you are using your own equipment and you are then passing it off to another party because you have designed into it the fact that that piece of equipment has continuity, that is a great way of addressing scope 3, and it's a great way of a corporate allowing themselves to be responsible, keep up with efficiency, but also managing a completely distant third party with a benefit. So I think circularity has a key role to play with this.
Thank you, Jay. And I'm going to flip back to Emily following that question. So from Vale Base Metals perspective, what role can the circular strategies cover in terms of decarbonizing the Scope 3 emissions? And how much effort should we put into Scope 3 versus 1 and 2?
So I mean, for a company like Vale Base Metals, where I would say we've spun out from our parent, we're on our own journey right now. Circularity is very important. I don't think a mining company out there doesn't have circularity in their strategy. I think uniquely to base metals is our relationship with the OEMs. We have very strong relationships with our autos, and I think there's a lot of opportunity as you look at battery recycle and how you keep that product within the value chain. So you're not having virgin product out in the market, but how are you creating a recycled ecosystem? Equally, I think one of the things I'm more passionate about at times is we operate in the north of Brazil. It's remote, it's agrarian. We have a partnership where we use our furnace slag, and we turn that into fertilizer, then selling it into the market and creating more of an ecosystem that can support our business longer term from some of our byproducts, and also reducing the amount of logistics and travel and the greenhouse gas emissions from our own third parties. But I think circularity has to be there. And I think, again, as we look at this journey in mining, we're all coming to the table on circularity. And I think in the next 5 years, you'll see a lot more innovation that comes with circularity. And I once had an oil company call me and said, "Did you know you can mine without mining? You can get metals out of your tailings." And I said, "Well, if you can crack it, give me a call." But again, I do think circularity has to be in the strategy and it has to be on the platform in order to tackle Scope 3.
And I think having circularity as part of the discussion really drives a lot of innovation, the potential for innovation. And that I think would actually open up a lot of opportunities that we hadn't even thought about. If we actually just talk about tailings reprocessing as an example, and I know we're going a little bit off, but there was a lot of elements that were contained in the tailings that a number of years ago we didn't even know. They were somewhere hidden on the periodic table.
Absolutely.
And nobody even knew about them, so therefore didn't get any focus. So the bigger picture of circularity, I think, is really important and key.
And I think really exploring non-traditional partners, right? If we go beyond our set ecosystem and look at where we might partner, and even we're headquartered in Canada, cross-border with the U.S. We can talk politics later. But the opportunities there, and I do believe in the next 5 to 10 years, you're going to see a lot of innovation and practicality have to be put in place.
Yep. Thank you. We have not forgotten about you. And so looking at the World Resource Institute, given that your focus on energy minerals, how can the mining industry adapt to reduce the carbon footprint of these minerals through their life cycle, especially in a world moving towards renewable sources?
Sure. Well, the clean energy transition needs many types of minerals, and WI currently focuses on copper, nickel, lithium, and cobalt. Actually, for these minerals, carbon footprint hasn't been the most outstanding issue, right? Just because the total amount of emission, for example, from cobalt and lithium is a few million tons a year. Copper and nickel is a couple of hundred million tons a year. And compared to steel and aluminum, that's in the order of billion tons, that's very small. But there's always a but. But the greenhouse gas intensity is much higher for these minerals. Take nickel produced in Indonesia as an example. That has a greenhouse gas intensity of 80 to 90 tons per ton of metal produced. And that's much, much higher than aluminum and steel, so per unit. And with the ore grade keeps degrading, that intensity will become even higher. And with the total volume keeps growing so rapidly, the total emission will also grow rapidly. So we need to look into it still, so it doesn't become a huge problem tomorrow. And for these minerals, actually most of the emission is scope 1 and 2. Right? Again, Indonesia, nickel, it's mostly from coal used for electricity, used for heat, used for the chemical reactions. As Emily said, there's plenty of things a mining company can do to reduce these emissions. If we talk about scope 3 emission, I think some of the scope 3 emissions, it's easier for mining industry to influence than the others. For example, a recent report published by the Cobalt Institute says most of cobalt production, scope 3, comes from the chemicals, sulfuric acid. So the mining companies can encourage their chemical suppliers to decarbonize. And then, remining, recycling, as the other speakers have mentioned, is another powerful tool because they typically have a much lower GHG intensity compared to virgin ore mining.
Thank you. Bhagesh, on to you. How can the mining industry leverage carbon markets to actually finance scope 3 emissions reductions? And what are the challenges in ensuring that these reductions are actually verified and truly effective?
So, thank you, Dennis. For mining companies, there are 3 or 4 things they can do by using carbon markets. One is, of course, every organization will have what we call unavoidable emissions. That is that no matter what they do in terms of decarbonizing and trying to achieve their targets, there will be these unavoidable residual emissions which will just stay. An extreme example would be a remote mining project where they have to use a fossil fuel power source, right? And they can't get rid of that. There's no alternative substitute. So one strategy would be to have to purchase carbon credits in the market and offset those unavoidable emissions. So that's one reason the company would do it. The benefits of that is you're channeling money into projects, carbon projects, that would otherwise not get financed. And and these projects are actually actively reducing emissions. So that's one reason for doing it. The other reason for doing it is also that it puts an internal carbon price on the company's emissions, and it allows the company to actually measure the cost of these emissions to the operations. And a lot of companies have now started to set internal carbon pricing as a KPI. So this is a KPI for various business lines and for even employees to encourage them to reduce energy consumption, which in turn leads to cost savings, because if they're reducing the carbon footprint, it's reducing the emissions. So one is actually just buying carbon credits. There's a whole different argument around whether companies should buy carbon credits, but that's one strategy that a lot of companies adopt, including mining companies. The other one is developing carbon projects. There are different types of carbon projects that mining companies can develop. The very nature of mining projects, mining companies and their projects is that they are in areas where they can use their vast land bank to develop nature-based projects. And developing these nature-based projects will benefit the biodiversity. It will benefit the communities. The question is, how does the mining company use it? They may use it for their own offsetting strategies, or they may use it to sort of monetize the credits by selling it in the carbon market. The third one, and there's a concept of biodiversity credits, which is where a mining company, particularly given the areas they mine in, they may be displacing or disturbing biodiversity, and they can go out and buy biodiversity credits, which will then compensate for the biodiversity loss. And those biodiversity credits trade at a premium to normal carbon credits, just given the nature of them. The third strategy is that, so developing these carbon projects, and the carbon projects the benefits are, again, benefiting biodiversity, local community, but also for a mining company, it provides a long-term stable supply of offsets for its unavoidable emissions at a cheaper price than what it may buy on the market. The third one would be technology, using technology. One of the things South Pole is doing right now is we are studying the feasibility of the carbonation of mine tailings. You talked about mine tailings. which is a mining waste made up of chemical residues, water, rock. They naturally interact with the atmosphere to capture the carbon dioxide and create permanent storage. There are other types of examples. You can use geological structures to capture carbon dioxide. This is not a new concept. A roadblock to it has been whether you can scale it up and whether you can make it economic.
Thank you, thank you. Appreciate that. I've been given the 5-minute warning, 5-minute bell. I can't chair this panel without bringing in the fact that we live in an ever-changing world. And post next Monday, the 20th of January, there's going to be a change in administration in the USA, with potentially less emphasis on the energy transition, climate change, and so forth. And I'm going to throw this open so that I don't put anybody particularly on the spot. But how would this impact our focus on emissions management, number one, and then specifically related to the challenge of measuring Scope 3 emissions? So, Jay, would you like to take that one on? First off, and I'm in the same question for all. Minute.
I think the world's focus on emissions has been in place for a long time now, and with any change in government, there are certain changes, and this probably is one of the most important changes in government. But in terms of the vast array of stakeholders that we in Verdigris engage with, whether they be finance providers or off-takers for a mine or a processing facility, it's going to continue to be very important to be a good corporate citizen, and that is to do with your emissions. I think it comes back to a different question. What is the role of government versus what is the role of the consumer? Now, I always assumed, probably 10 years ago, that you would be able now to walk into a car dealership and see a car that was made with non-green material and a car that was made with green materials. And rather like you do with your dairy or your eggs or your bread, or you will pay a premium for organic material or well looked after products. And I think people should be paying a premium for a product that has been responsibly sourced and produced. But people aren't. So that is, the market is the ultimate driver, and government has a role to play in changing that, and maybe a changing government will change attitudes somewhat. But I do think ultimately it'll be the market that decides these things, and that is a long journey, particularly when there is a cost of living crisis in key parts of the more developed and affluent markets.
Yep, thank you, Jay.
No, I mean, I agree. The market, the market drives these changes, right? And right now we don't necessarily see the incentive in the market as we should or would like to see. I think with the new administration coming in, right? I say this in my own business. We're a multinational. We operate in many parts of the world. Our customers in Europe, they're not changing course, right? And I kind of go back to the days of the methane for my non-American friends, where it was an issue, right? We really had to tackle it. But then it became very much a mainstream part of the oil and gas business is managing methane, right? And I feel that way a bit with emissions, right? We've been doing this a long time. We're not going to all of a sudden scrap all the work we did in a changing government, right? We're a long life business. So, as we set up ourselves and we look at how we allocate our capital, this is good business, right? And your customer sets change, governments change. And so, in a business like mining, when you're talking 20 years, you can't change every 4. And so, yes, I think you will see changes within, the North American market, yes, but we've done this before. I think it's a resilience in the system, and, sustainable businesses, or needed, and they will be, and I don't think that goes away.
Thank you, Emily. I'm actually going to give.
I can say a few quick words. Yeah, so although it's a pity that the US federal government might be reducing its climate ambition, but there are many other actors, right? State governments, corporates, many other countries and regions hopefully can still keep the climate ambition momentum going. And in terms of demand, although the US might slow down a bit in clean energy transition, but I think in terms of mineral demand, clean energy is just one of the drivers. There are so many other societal changes needs to be powered by minerals. So I don't think that's going to change.
Thank you very much. Anything last word?
I would just echo what Kerr said, that I come from Singapore, so essentially technically from the global south. What we are seeing is there's no let-up in incentives to drive down emissions. Indonesia is a good example. They've got a new president, and they're lifting the moratorium on the export of carbon credits. And so there's a huge drive on encouraging companies to reduce emissions.
Thank you very much. And I'd like to thank the panel for actually addressing a pretty gritty subject. Scope 3 is not an easy subject to get your head around. So thank you for your contributions, really appreciate it. And also to the audience, thank you for being here at this time of day. And
thank you very much. Thanks, Dennis.
Thank you.
Yeah. Good afternoon, everyone. My name is Jim Paterson. I'm principal of a group called Discovery Group from Vancouver, Canada. I'm honored to be the moderator today, Technology and the Lithium Revolution. Thank you very much for staying late. We've got some great panelists, speakers with knowledge on investment, academia, technology with respect to lithium. So we'll just start by rolling down from left to right the introductions of the three panelists, starting with Paolo.
Okay, good afternoon, everybody. I'm Paolo Guida. I'm a research scientist at King Abdullah University of Science and Technology, and I'm a founder of Circoli, which is a lithium battery recycling startup, a spin-out of KAICC.
Assalamu alaikum. Hello, everyone. I'm Saoud Al-Mindil. I'm the Vice President of Technology and Innovation from Ma'adin, the Saudi mining company.
Great. Thank you.
Yeah. Good afternoon, everybody. My name is Zipin Lai, and I'm a professor of KAICC in the program of chemistry and chemical engineering, and I'm the founder of the Lithium Infinity.
Great. Thank you very much. Saoud, we'll start with you. maybe just talk a little bit about your investment process, the criteria, and how you see the partnership between companies like Ma'aden and technology companies like the ones we have here today.
Surely. We are very proud of our collaboration and investment in Lehigh Tech Lithium Infinity, the startup coming from the KAICC University. This is truly a successful collaboration, and it can be considered a model of innovation collaboration in the Kingdom of Saudi Arabia related to the innovation in mining. The components of this truly showcase how a successful recipe can be made to exemplify to other academic or startup companies that are interested to truly take their knowledge and take their innovative solutions to application to help us solve major problems. As you all understand, when it comes to the energy transition, lithium is a major critical enabler that is required for electrification, EV, so on and so forth. But from that perspective, truly the dependence or truly the supply and demand imbalance required us to look for innovative solutions. This solution from KAICC University, this startup, we jumped into this collaboration at an early stage. In fact, we were very proud that this is coming from a local university, KAICC. Dr. Zipping and his team working there truly have showcased and proved the success of this on a lab scale, which truly interests Ma'aden and triggered our interest to take this collaboration to see how we can upscale and collaborate with this company to take it to the next level. We saw the right team in place. We saw the common goal and focus area, whereas probably some universities put some effort into areas that are maybe not of very much interest of industrial companies. But in this case, this was very much of an interest. This is the right focus. And from that, we took it into a collaborative approach with consistent and persistent sort of collaboration that was ongoing with adaptability. Probably I can elaborate further after hearing from Dr. Zipping and bringing here some of the success of year one results of 10 kilogram of lithium, which he guaranteed me that it's safe, it's not hazardous because it's lithium carbonate. So I'm feeling safe sitting next to 10 kilogram of lithium.
If not, move it down to me, I feel safe. Professor, maybe talk a little bit about why you think Ma'aden and KAICC invested in your company.
Yes, okay. So let me tell a little bit the history of the technology, how we developed, right? So, so in this forum, you have heard many times about lithium, right? Batteries and, so it's also now lithium is called like the white gold. It symbolizes how important of this element for the future, the renewable industry, energy, like future, right? So in 2021, and my research lab in KAICC, so we discovered a really, I would say, groundbreaking technology, and to extract lithium from seawater, and with a lithium concentration only 0.2 ppm. So at the very beginning, you can see that it's just based on a curiosity research, right? We just want to demonstrate that, as a researcher, and in a university, how can we solve a challenging issue that we are facing in the future, right? So then, and so after we discovered this technology, and then we received a strong support from KAICC. So they encourage us not just to focus on fundamental research, but also trying to commercialize it. So based on this encouragement, so we built this startup called Lithium Infinity. Yeah. And then, of course, we trying to approach companies and get support. And then, but at that moment, have to say, not many people believe it, right? And it's still challenge, and and also, especially when we wanted to find a solution within the kingdom, using the in-kingdom resources. And then I meet with Mr. Saul from Ma'aden. And then we had many discussions. And I have to tell him frankly, I said our technology, the success rate is only 10%, right? And maybe later we can hear from Saul how innovative mind he has, right? To allow him to take the risk, to invest us, right? To work with us. But now, I would say, now you see in front of me, I brought a bottle of lithium carbonate. It's extracted from the Aramco oil field, produce water. It's a battery grade. So with this, I can now proudly to announce that it's the official launch of lithium extraction within the kingdom using the in-kingdom source. And together, we wish that we will work with Mahadan, with Aramco, with the Minister of Industry and Mineral Resources and the KAICC. We wish to really build a knowledge-based economy and really wanted to position Saudi Arabia as the global leader in the transition, the future energy transitions.
Thank you. Paulo, maybe give some background on why KAICC invested in you or what the structure is, and talk a little bit about your company.
So other than the water, there is another resource of lithium that is quite widespread, and it's basically phone batteries or car batteries, I mean lithium-ion batteries in general. So one day we were looking at what are the problems in recycling batteries to recover battery-grade materials, and we figured out that the process is quite intense in terms of consumption of sulfuric acid in particular, the fact that you have to neutralize it before dispose it, and the fact that the infrastructures are really huge. In fact, most of the companies that recycle batteries are stuck asking investments over investments because they cannot keep the capex at an acceptable level. So we said, okay, let's try to intensify the process. We developed a new reactor for leaching and a new reactor for crystallization, which are two steps of the hydrometallurgical process. And we figured out that we could reduce by 20 times the footprint required to recycle lithium-ion batteries. Also, we are doing it by using acetic acid instead of sulfuric acid, which has much lower carbon footprint, slightly higher price, but we end up having a product, a waste product, which is actually something that you can sell instead of something that you have to dispose, which is sodium acetate. So we said, okay, this makes sense from an economics perspective and also from an environmental perspective. We just went to KAICC. We said, okay, we have this technology. We want to prove it at some level, and we received investment from KAICC. After that, we were in contact with Saudi Investment Recycling Company, CERC, and we are actually negotiating now how to move this further to eventually have a pilot system at a larger scale and next to KAICC, like 2 hours from KAICC. We already have a pilot scale plant that processes 50 kilograms of black mass, which is the cathode material, the valuable part of a battery, per day. So yeah, 20 tons per year, more or less.
Great, thank you.
Thank you.
So maybe Professor Lai brought up that you had that vision, you took a big step and risk with a technology that only worked 10% of the time. So is that a culture within Ma'aden to allow you to do that? Maybe explain that.
Sure, that's a good point. So it is known probably within the M&M, the mining and minerals as a sector, that it's a risk-averse industry. From that perspective, Ma'aden truly have put very ambitious targets of growth for the company to grow by 10x by 2040. That growth will not happen by the technologies we had in the last century, probably, number of decades. It truly required us to innovate. That coupled with the energy transition pressures, imbalance of the availability of some of the critical minerals, truly Ma'aden have put as an innovation strategy that required us to truly take certain levels of risk. That's definitely a calculated risk, whereas the confidence probably in some of these emerging technologies is not high in the beginning, but where we work with our partners globally within our open innovation framework to ensure that we increase the confidence as we go. With that, there's a very important element, which is adaptability and agility. When we started, it was very ambitious target to have lithium from the direct lithium extraction, DLL sort of technology from local sources in Saudi. In fact, we were not targeting oil field brine when we started, which Dr. Zipping knows very well. The whole project starting with a very promising ambition to say seawater. The entire seawater can be something to work with. The research from Dr. Zipping that he can tell us, it can do it. However, the economic feasibility is also a very important aspect when it comes to commercializing any of these startup technologies. So we then started to look for alternative within Saudi sources. So we started looking within Ma'adin, if any of our feeds from some of our different commodities, whether from our bauxite processing or from our phosphogypsum or from our phosphate. And we ended up getting results that are still not very encouraging. Here, the latest adaptability, and hence the announcements you heard today, which is the collaboration with Aramco. In fact, the oil field brine became the right source depending on the concentration we were able to get, which helps us to do this in a commercial scale, feasible way. And hence, you heard today the announcements with their excellencies a while ago, and the 10 kilograms sitting here, which now is also only paving the way to go further into our upscaling of this very promising potential to start to extract lithium from oil field brine in Saudi, and technology coming from a local university, invested by a local, the mining champion of Saudi, and now turning the sources of the Saudi oil field brines to extract further value from it to help us in the energy transition that is required on all of us.
I must say that globally, I've invested in several technology companies around the world at the early stage, and the big challenge is to commercialize, or the hesitancy for the established mining or oil and gas companies to adopt technology and incorporate it. So, Professor Lai, maybe talk to us a little bit about maybe why you're blessed to be in Saudi Arabia, getting the funding from groups like Ma'adin and KAICC, but also looks like commercial acceptance from some of the biggest players in the world.
Yes. Yeah. So just a few half hour ago, right? We hear from the Minister of the Industry and the Mineral Resource, right? So he said now is the time to do innovation in the kingdom, right? So because the kingdom has the brand, okay. Also, we have a strong support from the industry. I would say this is exactly what I'm facing. I'm very, very lucky, I got a strong support from Mahada, from Mr. Saud, right? I'd already mentioned, even at a very, very high risk, right? But they're willing to take the risk and support. Yeah. Frankly speaking, in the last 2 years, we formed a strong team. I mean, this team is not just the researchers from KAICC, right? We have get a strong support from Mahada. Mahada I would say, inform probably more than 10 people, right? And really, support us from all aspects. And as already mentioned, we are trying to look for in-kingdom resources. And then, so Mahadan suggests us, why don't we try like oil field produced water, right? Even this resource is not kind of like, from Mahada. But immediately, Mahada and Aramco form alliance and support us. So I think, with all of this support, it's really, you can see in 2 years, we already can make a almost impossible job to be, I would say, at least quite promising right now, right? I mean, if you look at really, the technology development from a laboratory work to like a industrialization, right? Normally take 20, 30 years. I think, now we are able to achieve it in 2 years. I think this is really, is benefit a lot from the collaborations between our university, KAICC, and also Mahada. Yeah, it's really, I would say, this environment is super important.
Yeah. Yeah. Standout results globally for sure compared to other projects around the world. So Paulo, maybe talk totally different sources, or maybe explain to people the technology that you're working on is global in terms of its feed sources, correct?
Yeah.
So describe maybe the differences there.
So actually, the best places to deploy our technology would be places where EVs are quite widespread.
Okay.
Because and also power accumulation, like with lithium iron phosphate batteries, because our technology works better with the kind of chemistry in the batteries for EVs or for households and so on, batteries used in households and so on. So the idea we have right now is to develop a technology in Saudi and apply that elsewhere. The fact that we are building the reactor itself, all the pieces, all the technology, all the software in Saudi Arabia, and then we are going to deploy it most probably initially in Europe or in the US, that's something quite new.
Yeah.
Because we not only exploit our research that in the future is going to be widespread here as well, but we are kind of exporting technology. And this is, I mean, we're really proud of that. That's something that we really want to do, like having made in Saudi Arabia and the technology sector stand out.
But it would have application, let's say, as mining fleets get electrified around the world and in country, those, in time, you'd be recycling those batteries?
Eventually, one day, there's going to be more lithium in batteries than lithium to mine, right? If we keep extracting. So it's only going to grow in time. We are actually thinking of applying this to minerals as well, to processing of minerals directly, not only for cathode material. I mean, it's a bit more complicated, but that's something we are looking at. Anyways, yeah, that would enable a more sustainable electrification.
Great,
for sure.
Thank you. So Saad, when you think about investing in companies and building up the infrastructure and investing in the kingdom, how much are you thinking about taking the technology and the commercialization to a global stage? Is that part of what you're thinking as well?
Definitely it is. In fact, probably we heard it from His Excellency, the Minister of Industry and Mineral Resources. This is a land where dreams do come true in terms of the implementation that we take seriously. It gives me a little bit of nostalgia. Only a couple of years ago, we visited the labs in KAICC, and we saw the small experiment in the lab. It was able to extract lithium from a small water container.
In milligrams.
In milligrams, absolutely. And then fast forward a couple of years after, one FMF, we signed the investment agreement, we were convinced, then we built the manufactured the equipment, and here we stand with the results of this, truly the facility, the bench scale that have been put in KAICC, from oil field brine coming from Aramco. So the lithium demand is not Saudi only, of course. This is a global demand. However, we heard from our leaders, we heard from many of the executives regarding the demand and supply imbalance globally, and the needs truly to secure supply chains when it comes to critical minerals. So from that perspective, here in Saudi, we are also truly activating the different innovative options that we have
today. And today we will be speaking about the role of technology in helping supply countries to enter a new era of minerals. My name is Konstantin Liakov from Kearney. I will be the moderator of this fantastic session. And let me please now introduce to you our distinguished speakers, panelists. These people actually work at the intersection of technology, innovation, sustainability, and of course mining. Maybe I will start with Ms. Flavia Tatanardini, co-founder and CEO of a company called Fleet Space Technologies. Flavia will tell us later about what they do, but one remarkable fact I can add, last year your company has become a unicorn. So this is very exciting. Then I would introduce Dr. David Zhen-Yin. He's a program director and co-founder of Stanford Mineral X Initiative. Nice to meet you, David, and we will looking forward to hear from you interesting things. And last but not least is Chris Page, Executive Vice President of New Business Development at Viridian Group, which is a global leader in geoscience solutions and more, many things in your portfolio. So let me maybe start with the reflection. So we are talking about the new era of players. Traditionally were relying on very labor-intensive methods on how to locate, evaluate, extract minerals. No? But now with new technologies of AI-driven data analytics, seismic imaging, and what else, these processes are becoming faster and faster and more efficient, and the risks are going down for investors. And I know that, well, everybody wants to adopt now new technologies, not only emerging, but also developed countries in the era of exploration. So maybe can you tell us a little bit more how is that your company and what you are guys doing in this like new technology space? Yes.
First of all, I really want to say that I am not a geologist, I'm not a geophysicist, so I'm a rocket scientist. And, and I founded a company coming outside in into an industry that I didn't know before. And I have fallen in love with now. An industry that is really solving big problems, like the industry I come from, the space industry. As I always say, it's all rocks, just big planets and rocks underneath. The thing that really fascinates me the most when I started working and built fleets, because I'm one of the co-founders, so it was a dream, 2 people in a dream, and now it's 10 years in and more than that, was the time. The time. How long it takes to do anything in mining. It takes 12 years to find a mine. It takes 17 to develop it. It's a long time. It really reminded me profoundly of my industry, when we were used to build rockets in 20 years, just with NASA and multi-billion dollars. And we never thought that could change. Never thought that could change. We always thought it's going to always take billions of dollars. It's always all going to take 20 years. And 6 hours ago, Fleet has launched our satellites number 9 and 10 with SpaceX in the sky. And without SpaceX, that launch its own rocket and land them and launch them every week, my industry would have never changed. So I've seen a transformation in an industry that was very, very similar, and that drives me. So time, it's money. And humanity doesn't have time. And net zero is around the corner. Time is the problem that I want to solve. Speed is the problem that interests me. So when you look at discovery and exploration, it's a huge amount of data that in the past 40 years we have collected, not just in the past 40 years, at the time of the Bronze Age when we were stumbling on a copper walking around. There is a huge amount of data, there is a huge amount of land, and there is little time. So my vision was if we enable every geophysical technique, so geophysics and geology are 2 beautiful arts of understanding the world, beautiful, on different sides. If you really enable every technique that is in the field to actually be connected to space, real time, and that connected to a cloud where you can run AI real time, not in 6 months, not in 6 weeks, in hours. What can you achieve when you can give insights at that point in time? So this was my thesis, because I couldn't believe that how cyclical exploration is, that you go into the field and you leave probes for months. I couldn't believe that you cannot make a decision, that a drilling campaign is planned. And when I looked into that, I realized, okay, we can do this. So we blended these 2 words together, the word of space and the word of minerals. And these 2 words are actually very similar. We are all explorers. We all want to solve very complex things. And I didn't want to go with the status quo. So I said, we're going to start building sensors and geophysics that is real-time connected to space. And see, with the idea to reduce that 12 years of finding a new deposit to 1 year, maybe 2 months. Everyone, even my team, thought we were crazy. And they were telling us, why is space needed? Why do you need to connect things to space? Why do you need to make it so complicated? Can be easier. We have been doing this for 50 years. What if you're processing data happen in 6 weeks? Who cares if it happens in 1 hour? I guess a lot of people told that to Elon Musk and SpaceX. Why would you land a rocket? It's not important. It takes us 10 years to do this. And it's changed the world. Starlink connects every country around the world. It connects billions of terminals, people in the middle of nowhere that have connectivity to the internet. It has changed humanity. And it's changed humanity because it's creating a speed element in an industry that now needs to go fast. So that's what Fleet does. So we manage our constellation satellites, completely dedicated to mineral exploration. We build probes for geophysics that are connected to space. And we want to build all the suites of them to make sure that real-time decisions are made and use space as an enabler to bring data in the cloud. They use AI. So if you look at how big the planet is, like how big it is, and all these countries that now need to look for minerals, for me, it's a matter of time. I don't have 330 years to find all the copper and lithium that we need to find. I personally don't have 50 years, maybe. Okay, I'm in my 40s. So I want to change the status quo. I want to make sure that my kids live in a planet that is sustainable, and we don't have time. So we implemented all these real-time technologies, and it takes time for people to understand why this is important. But suddenly we are seeing the results. And, and interceptions happen in months, not years. And deposit gets found much faster and more efficiently. And this excites me.
Oh, interesting. Maybe one question on top of that. And we were talking in the background, and your brother or yourself mentioned that actually the attention and the growth of the business you are in has come like only a few years ago. Like, what has changed?
So what we do is deep tech. So we decided to go an end-to-end solution, going from super modern geophysical techniques, so building sensors. Like when you listen to Earth, Earth is very noisy. It's a beautiful planet. Our sensors got gigabytes of data a day, and we needed to shrink with edge computing into kilobytes to send them through satellites. We 3D print our satellites. We are the only company in the world that does that. And we had to make it small. Satellites are usually $1 billion of big little bus, and we made them very, very small. So we could change the economics in the sky and connect things that were impossible to connect. And then send all this data in the cloud and do all sorts of AI and modeling in hours. Doesn't get more deep tech than that, okay? So for 7 years, we just had to build tech, and new tech with Silicon Valley, and it's just like all the new technology possible with a thesis about market fit. So in the past 3 years, what I think is really changed, what I've seen change it, is the urgency. So when we went into the market, in 2 years, we were many, many countries, and it's not easy, and it's still a lot to do, but I've seen in the meanwhile a change in the industry. So deep tech are hard to build. They take years. So you need to be patient. But when you hit the ground with your deep tech product, you go. Like your moat is too big. Like we got our global data acquisition system. How can anyone catch us? But you need to be patient and resilient.
Yeah, resilient, that's definitely. Maybe Dr. David, a question to you. Well, historically, supplier countries were focusing only, I would say, on export of raw materials, and leaving quite some value to other places in the downstream part, with processing and manufacturing. Now everybody understands that we want to move along the value chain. We want to get more value from what we have in the ground. And I've seen, and I've heard today a lot of messages like this. It's very clear why it needs to happen, because I mean, you can't just export raw material. You want to create jobs. You want to have GDP, increase your GDP. And well, Saudi Arabia is one of the examples with the national industrial strategy, with the mining strategy. All of them have objectives to create value in-house. And from your perspective, how do you see and what are the ways of collaboration between supplier countries and research institutions actually to develop these new technologies, this innovation on the ground?
Great question, and also a very big question. We are, Stanford Mineral X has become one of the largest research hub at Stanford University, just by, focusing on critical minerals, and also by collaborating with the mineral supply countries. One of our technology has been, used to discover a major copper deposit last year in Zambia. So we see great opportunities with the supply countries, regarding, for future, I think I'm a geoscientist by training. I always look into, start looking into where, the resources come from. And if you look into the fundamental reason why the supply country has been there as a supply country is because of the geology and in favor of those resource endowment. They are heaven, and the geology cannot change. It'll be there. It was there. It formed hundreds of millions of years ago. It's keep being there regardless of, a human being exists or not in the future. So I think one of the biggest thing is to, to focus on exploration, to find out more resources. As long as you have more resources, you're going to have more options. When you have more options, more resources, you're going to attract a lot of investment. You're going to have more people who want to come to develop your resources. Once you have the investment, comes the infrastructure, comes to all those service companies come in, giving you the technology. You have also the infrastructure teaching the students, and then so finding the resources. There are very lot of cutting edge technology. The free space, the ambient noise tomography, very agile, and you can move around very fast, and on the country scale, find out the highest grade deposit, and then that becomes the most sustainable, environmental and sustainable deposit, and also economical viable deposit. So that's just an example, but really focusing on the fundamental. I think it will be very important, and also having education, having the proper workforce being trained. I'm from research, education sector. What we see here is, if you look into the at the high level of the supply chain, mostly the Western countries, developed countries, there is a significant decline of the workforces for the mining sector. Which becomes their disadvantage, but it becomes advantage for the supply countries. And when you are having significant amount of investment, and also have those technology available, that's available, you want the workforce available to use those technology to find out the deposit fast. And then you build about the processing facility. You build up, you do the mining in an environmental way. You need new mindset. You need new talent of leading that change, and also having an ecosystem that can foster this collaboration. Yesterday, I attended this, the Center of Excellence initiative, and I think it's a great regional initiative by putting together all the research hubs, and with a focus on Africa and also Middle East, and that's going to have this environment of boosting innovation, and also I see, there are universities there, I see there are companies there, and I think this close collaboration between the industry and the education sector is going to make sure the transfer of the technology becomes super fast. And in terms of the time limit and the urgency of development, we need to boost that process. And I think those are the three things that if we do well, it will be a great success.
Okay, and are you collaborating today with any institution in Saudi?
That's why I'm here. We are looking for collaborations here.
It's a year of action, as I heard, no?
Yes,
I think
yes.
We want more, no? And you should really like focus, no?
Yeah, we're very happy part of the Center of Excellence, and we look forward to the future collaborations.
Okay, we'll get your word on this. So, Chris, new technologies, no? And well, mineral industry now, as far as we see, is embracing all the technologies that are available, as far as it seems, no? From digital twins to predictive analytics, whatever else can come in mind, no? And all to improve efficiency, safety, to get better. So what, from your perspective, and you kind of have, you're also in geoscience, but you work also with other industries, and you have other technologies in your portfolio, is where do you see the most transformative technologies today for the future of the mineral industries and supplier countries?
So thank you, Konstantin. And just to give you some background on Viridian, we are probably the leading geophysics company in the world. And that's really with a focus on multiphysics and active seismic as well. My story is probably going to be fairly similar to Flavia's, but with a slightly different slant on it. What we see as we embark upon our journey into the mining sector is that there's pretty widespread adoption of some very traditional geophysical approaches. So when we look at the exploration space, we see a lot of work in multiphysics, in gravity, electromagnetics, etc. And that's been very successful for mining and other industries as well. And Viridian has a long history, 40 years of working in this space. But I think what the challenge for me comes, and the acceleration and the effort that we need to see in terms of efficiency and safety comes as we get closer to discovery and development of resources. As we come closer to discovery, the traditional approach in other sectors would be to switch to seismic, and we've talked about passive seismic, but also active seismic. And that's what, for example, in the oil and gas sector, really brings the resolution and the understanding of the subsurface that enables companies to efficiently exploit those resources. The challenge that we see in the mining sector is that we haven't seen good algorithms and good solutions to solve active seismic in the hard rock near surface setting. And what the result of this is that the engineers and the geologists tend to reach for the drill bit. And this is where our inefficiency and our safety concerns start to come in. So we see, in order to define a resource, we see thousands of wells being drilled, which of course is an incredibly high-risk activity, probably in the exploration and development phase, one of the highest risk activities that we have. Fortunately, as Fleet have talked about, but also as Viridian have been working on over the past few years, there are now new higher-end algorithms that can solve the real physics of the wave equation. So we're now implementing full wavefield inversion, which is a technology that we developed in the oil and gas sector to solve some of the most complex imaging challenges in the world. We've started to apply this into the hard rock environment with some really significant success. So we have a recent study in southern Australia when we used full waveform inversion to image for BHP. And not only were we able to significantly improve on the structural elements of their deposits, so we were able to identify with a great degree of accuracy the controlling fault, and we were actually, through the high resolution velocity fields, we're able to identify the ore bodies themselves, and also identify ore bodies that they'd missed through conventional approaches as well. So for me, the data, the subsurface data, building a clearer understanding of the subsurface before you reach for the drill bit is going to enable us to have far more efficient drilling programs, potentially reducing drilling by 15 to 20%, and the subsequent impact that has on cycle time reduction and on the reduced exposure in terms of that high-risk activity. So I think really what we're looking at is using better geophysics, solving the physics better, producing better images that allow us to go much, much faster from discovery through to production and then getting our minerals to the market in the future.
Amazing, fascinating, I would say, all the things that, that you say. I would ask this provocative question. And you work with the oil and gas and mining players, no, today. And if you compare those two, no, like who do you think are the more agile, the more like fast to adopt new technologies? Just out of my curiosity.
So this really depends on a company-by-company basis. So we see companies in the mining sector that are very fast at adopting technologies. BHTP I've already mentioned. We've been talking with Marden and Ajlan. They really want to bring technology in to help accelerate their process. It's a big challenge in Kingdom. You know, we've got a big challenge to face here. We want to really boost that third pillar of the economy. So there is a real desire for technology in certain areas of the mining sector. If we contrast that to oil and gas, it's almost exactly the same. We see some companies that are very keen to develop new technologies and some who are quite happy using traditional approaches. We used to see a general split between NOC and IOC, but that's gone now. So we see some NOCs that are really pushing hard on technology and some IOCs that are using much more traditional approaches for exploration now. So I couldn't split between the two sectors.
So it's not about industry, no? It's about
the company culture.
The willingness to evolve, and that's about people at the end, no? So who is driving that? Oh, thank you for sharing this this thought. Maybe I am cautious of time, no? And I would like also to ask this maybe last question to each of you, no? No doubt that today Saudi Arabia, and this is Future Minerals Forum 4th edition, no? And I've been to 3 of them, and it's always been only growing, no? And in terms of people who are coming, interest and passion that we see here. So definitely Saudi Arabia is serious about to become a global powerhouse in the mining industry, in the mineral sector. And the question which I want to ask you is twofold. So on one side, what key challenges do you see for Saudi Arabia on this path, no? In terms of, I don't know, technology adoption, capability development, you name it. You know it better than me. And the second part of the question, where do you see the greatest opportunities for the kingdom for innovation and collaboration to make its journey successful? And maybe I'll start with Flavia.
Listen, clearly I'm here and very proud to announce a JV that we are doing in the country. So clearly we are committing to the country. The question is why we're committed to the country, because it's I'm so impressed of a country that comes together to put a 2030 vision so well clear. We were talking that it's like putting KPI in a company, right? Okay, we're gonna get there, you have to make it happen, and then having what, 40, 50,000 million people that have to make it happen. I think it's very inspiring. This country has changed so incredibly in the past 10 years. And I think, I always make this joke, who is going to be the Saudi Aramco of hard rock? Yeah. Probably someone in Saudi. And now this country knows resources. And they know how to use resources, they know how to collaborate, they know how to make it happen. The challenge is that Saudi Arabia is big. Like, it's a big country. And I come from Australia, it's a big country too, eh? It's a big country with a lot of terrain and not a lot of time. 2030 is around the corner. There is a fantastic company, Madden, with a lot of pressure to find things really, really fast. And there is a culture that needs to be understood. And you need to be here. You need to create friendship and relationship and partnership, because this is not a problem that we solve it by ourselves. This is a problem that we solve it together. And that's what I really think about Saudi. And on top of that, I don't drink coffee, and I love Saudi Arabian coffee. So this is why I keep coming here, because it keeps me going.
Thank you. Yeah. David. So I think the biggest challenge is changing the mindset, because you know, technology you can learn and develop, and working force you can train, the business you can develop and foster the environment. But mindset, you need a brain transplant. And the mindset of realizing that we are moving away and we're going to eventually shift away from the traditional fossil fuel and embracing the mineral world, I think is the biggest challenge. But I'm seeing Aramco's both is just in front of us. I think, you know, the kingdom is realizing this challenge and is embracing this challenge. This is amazing, and also the mindset of changing the traditional mining practice. You know, the mining sector is actually even have a worse reputation compared to the hydrocarbon sector, because of, you know, the practices over the past 100 years, and a lot of mess left behind. That we could, if we do this for the energy transition, we couldn't repeat the same practice. Yesterday I finished reading a book called Design Sustainable Prosperity. I think the author is here, Doris Hiam Galvis. I think she provided a lot of very good solutions on that, and I highly recommend that book to that. And because not like oil and gas, you know, you deplete the reservoir, you can fill that with, you know, with water or whatever. You can also inject CO2. But with the mine, I mean, the mess left there, when you abandon that, it's going to be the mess for the future generations. It's going to be a hazard for them, which we shouldn't do that in the traditional way. And also, you know, technologies are the mindset of transferring the technology from the traditional hydrocarbon sector to the mining sector. Is actually in the hydrocarbon tech sector, a lot of technologies are way more advanced and can be directly applied to the mining sector. They have high fidelity 3D models, and a lot of softwares can be used for mining 3D model. And the drilling they are doing, the way of drilling is way complex, and they can drill to whatever direction you like. And also using multi-physics data, and also very agile of accepting new technology. Technologies like ambient noise, technologies like, you know, seismic, and those are very essential for if we want to boost the supply and if we want to do it fast.
Great, thank you. Chris?
So I think one of the challenges that we face in Kingdom, other than the scale and the mindset, is it's a very young industry in the Kingdom. Well, it's actually a very old industry, but there's a current impetus that makes it a young industry. And there's a clear desire to accelerate the 2030 ambitions, but there's a lot of solutions that they could choose from, and there's a lot of providers for those solutions. So I think there's a real challenge in understanding where are the best places to go, how do we find the right solutions, but then also in terms of all the slowdowns that brings, in terms of procurement, in terms of finding people to fill different parts of the jigsaw. So I think that's a real challenge, and I think something that as service companies we need to look at. We need to look at how do we collaborate and how do we form partnerships within Kingdom. And Viridian is part of a partnership with Al Khoraiff, and along with a couple of other companies involved in that partnership, we're able to be a full solution provider, all the way from early stage exploration through to drilling and logging, and we can provide that service for our customers to really give them a one-stop shop almost to go to simplify that process for them. So I think collaboration and partnership amongst the service providers to simplify the solutions for our customers.
Oh, no, thank you. A lot of keywords like collaboration. Technology is not only one solution. Collaboration, mindset, passion always needs to be there. No, thank you very much. Let's give an applause to our panelists. Thank you.